So Chris, it's great to be back here at the Middlesbrough site. I think it's over 2 years since I've been here, and you do kind of forget how large this site is. I know it's like the largest in Europe for Univar Solutions, but obviously it's where you're based in our laboratory, looking at the innovative products that we get from our suppliers.
Yeah, it's been good to see and have you back in the lab and doing some work alongside myself. As you mentioned, it's the largest site for Univar Solutions in Europe, and we've made a lot of investments, basically firstly in the lab, where we've invested in a lot of new equipment such as a salt spray chamber, a colorimeter for measuring colour, and abrasion and scrub resistance tester, which allows us to do further testing than we could do in the past. There's also been a lot of investment on site in terms of the facilities, in the fleet that we use to deliver our products, to make them more environmentally friendly and more sustainable. In the lab itself, we've also got the facilities to test a wide range of products, from your standard architectural and wood coatings, to UV coatings, thermoset products like epoxies and polyurethanes, and construction chemicals and adhesives.
Yeah, I noticed the new Hobart mixer that you've got for construction products, for cement-based applications.
The Hobart mixer, it's essentially a cake mixer, but it allows us to mix things like tile adhesives, mortars, things like that in a more accurate manner, and it allows us to get the better performance. So it allows us to do sort of adhesion testing and open time testing, sag testing, and that, along with our coating things, gives us a more diverse portfolio to support our suppliers and customers in the case industry.
And I guess for the coating side, a lot of our customers are moving to waterborne coatings in particular, more environmentally friendly, and we do have a lot of products that
it's a focus of Univar Solutions as a company to focus on sustainability and environmentally friendliness. As I mentioned before about the site and the investment there, this site originally used to be part of British Steel, and it's been transferred over the time to be used for Univar, and the lab itself used to be used for analysing coal, and it's now been changed so we are able to support our customers through a range of testing. It's good that to have the lab in this area as well, because the UK is such a big market for the case industry for Univar Solutions. Also, in such an area as this, which has such a history in the chemical industries, with some of the biggest suppliers in the country of being based here, and as well the massive force of the steel industry in the area. So we're really proud that we're in the centre of Middlesbrough and we're in this industrial heartland.
Yeah, but obviously you do work for all our customers across Europe as well.
Yeah, we are a European lab. We support across Europe, Middle East and North Africa, and we can provide support to customers and suppliers in any of those regions.
It's been great being able to do some work in the lab with you again, with a particular focus on the waterborne coatings and wood varnishes, which is real focus for our customers.
Yeah, it's been really good, so we can actually sit and test a lot of our additives, because we've got such a range of additives which we are able to sell across Europe. Because of that, we've actually done a bunch of tests which will show the performance advantages of using certain additives over others, and adding things and using different resins, and the performance differences.
Okay, well, why don't we take a look at some of the experiments we've been doing over the last couple of days in the lab?
It's important to start first with the manufacturing process, because essentially we can't test anything if we can't manufacture it, and we need to be able to simulate the realities of the situation.
Yeah, like you say, you need to be able to simulate the production of the paint that our customers are going to use. So obviously it's great that you've got a Dispomat mixer in the lab, so you can actually produce the paint in a way that the customers will be producing it, and then you can test the products that we have that can be used.
Yeah, it's really, like you say, it's really important, because one of the key things of what our customers do, there's no point in being able to do something in the laboratory and then not be able to scale it up to an industrial size. So the Dispomat allows us to produce that and look for defects. Like, for example, in what you can see on the screen right now, you can see some foam issues, which can cause a lot of issues in the coating, in the intensity of the stir, and because you're having to mix the TiO2 pigment in, you're having to really hit it with quite a lot of force. So the problem with that is it can impart quite a lot of foam, so if you don't make the right deformer selection, it can cause quite a lot of problems.
You can see there it is really high shear when you're mixing and adding that pigment there.
Yeah, it's basically, like you say, there's a lot of additives in there like dispersant additives, thickeners and things like that, which will allow performance properties at the end, but at the point you need to get them in, you need to be able to mix away and you need to be able to get that high shear, and particularly for high colour paints like this will be, so you do need to mix it away.
And also the products you've mentioned, like the surfactants and the dispersants, they're all going to cause foam as well in the formulation, so you're mixing it, you've got foaming raw materials, which is why it's so important.
It's definitely a balancing act, because you've got to look at the sort of thing where you can get that sort of balance. You want to be able to get the vortex so you can turn away, you can spin away and add the pigments, powders, whatever else you want to add to the formulation, but you don't want to totally wreck the formulation by causing defects or causing too much foaming, because once it's applied it can cause issues. As you can see there, you get the addition of the deformer that will lower the density. You can see on the screen there the paint with the deformer. You won't get the bubbles in it, so from the manufacturing phase it hasn't caused an issue.
Okay, yeah, great. Well, why don't we take a look at what you can do in the lab in terms of the application of the paint as well.
One of the key areas for foam and deformers is during the application process, because if you're applying a paint where you apply it onto a surface and you're getting bubbles in the surface and the bubbles pop, they'll cause defects, and it's where you can end up damaging the substrate because it hasn't fully coated, because they're essentially little holes all throughout the surface.
That must be particularly important when you're applying it to metal as well, because you'd imagine if the metal's not covered properly, water can get in there and then rust will start coming through your painted surface.
Yeah, definitely. You can see here the first one is an example of a paint with the deformer added, where you can see there's not really much at all foam. Whereas the second one is a paint where we're looking at without deformer, and you can see in the paint itself there's already some little bubbles there. So during the application process, which is obviously a relatively forceful process, even with the more basic type of rollers, you do see lots of little pinholes which will cause a problem. One of the other issues, which isn't mentioned as much for foam, is that it lowers the density. In a manufactured process, you don't have the same amount of paint because the density is lower, you don't have the same weight of paint.
Yeah, paint is sold by litres, isn't it? You would buy a 5 litre can of paint. So if the density is low, because the defoamer's not working properly, you get less paint for your money.
Yeah, and it's costing the customer more in the end.
So we've really seen the importance of defoamers in a paint formulation there. But what about rheology modifiers and thickeners?
Yeah, it's really important to get the rheology right, because there's such a variety of ways of applying, and you need to be able to have that strength so you don't get any sagging or brush marking when it's applied, but you also need the viscosity lower. Generally, cellulose ethers are the most commonly used, and in some cases you're best looking for the high performance ones, which have been modified specifically for coating use.
We can see here you were just applying a paint with a standard cellulose ether, not one specifically for use in paint. And you can really see here when you're rollering the paint out, the spray that you get from it. And imagine if you were doing that at home, on your furnitures, on yourself, on your dog. But if you can use a modified cellulose ether, which we sell specifically for paint applications, then you can see here that there's no spray there at all actually. You're applying the paint on the card and that's where it's staying.
Yeah, it's really important, because like you say, it ends up just being wasteful if it's spraying everywhere else. And it generally affects a lot of other properties, such as like sagability and stability and things like that as well.
So we've looked at the defoamers and the rheology modifiers and how they impact paint performance, but I guess there's still other challenges really for interior wall paint.
Yeah, one of the things you would actually look to test after the paint is applied really is some like scrub and abrasion type resistance. Scrub in particular is very important, because you see a lot of people who've got young kids and things like that, when they draw on the wall, you need to be able to clean the surface. If you like have a spray up, if you're eating a curry or a chili or something, you get a bit on the wall, you need to give it a wipe. So it's important that the coating stands up to this cleaning.
So I think this is another new bit of equipment.
Yes, it is. It's our scrub and abrasion tester. In this case, we're going to use a scourer head with a certain weight on. You can adjust the weight or the type of head. We have two panels here. On your left, you have a coated panel with the silicone additive. On the right, we have the same material without the additive. For this test, we are going to place water onto the surface, a set amount, pre-weighed. For this, you could also add soap or things like that. You're going to switch it on and allow it to move back and forwards to simulate as if you are scrubbing the wall. And in this video, it has been sped up to show this passage of time. But as you can see, the panel on the right without the silicone additive eventually will begin to break down and remove from the surface, whereas the panel on the left with the silicone additive does not show the issues and shows very minimal damage comparatively. So it would be a lot more durable in terms of being able to clean and wipe in your home paints.
Yeah, you can really see the difference there, can't you? And I guess another way would be to maybe weigh the panels.
Yeah.
If you can't see a visual effect the same, you could weigh them and see how much paint's been lost.
Yeah, that's another way we can test that.
So I think we've shown some really good tests there for interior wall paint, but I guess waterborne wood coatings have new challenges.
A lot of our customers are producing waterborne wood coatings, and one of the problems when using in areas such as bench tops, kitchen tables and sideboards and things like that is stain resistance. One of the things we can do in the lab is test various chemicals.
Yes, and what we did yesterday was we did look at the stain resistance of 2 or 3 wood coatings and could really see a difference in performance. So we looked at quite a few different, chemicals, but products that you would find in the home, in the kitchen, on the dining room table, for example. So mustard, vinegar, coffee, curry paste, blackcurrant squash, which I think maybe is quite a British thing, I'm not sure, but also a bleach-based cleaning product.
Yeah, because see, one of the key things here is when you're in your home, as we mentioned, you don't want to spill something on your kitchen table, your bench top. You don't want to spend your money going to IKEA and buying yourself a nice table and then spilling something on it and putting a nice stain on. So getting the right type of coating is important. In this test here, we've got 3 different coatings. The one in the middle is a standard acrylic product. The one on the left is an acrylic with a polycarbonate crosslinker, and the one on the right is acrylic PU hybrid. So basically for the test, what we actually did was prepared these panels, allowed them to cure, and then we placed the 6 common kitchen chemicals on the surface and left them for a set period of time. After that time had elapsed, we wiped these away and wiped down with water, and then afterwards visually assessed for staining.
It's quite a severe test, isn't it? You're leaving the substance on there for 30 minutes, I would hope. If it was your table at home, you'd wipe it off quicker.
But it's very easy to forget sometimes.
Because it's a severe test, you're really going to pick out differences in performance between the products.
Yeah, as you can see there's a difference from the right one, which is containing the polyurethane in terms of the curry. Like in the standard, there's some staining from the mustard, which is in the top left there. There's some very clear stain from the curry paste. There's some staining from the bleach-based cleaner. And also some staining from the coffee. When you add the crosslinker, you do see some improvements, but you still see a very clear stain from the curry paste. And there is some marking present when you use the bleach-based cleaner. And on the right, when you use the polyurethane acrylic hybrid, you see a lot less of a stain on probably the most severe one, which is the curry paste. But you also do see some marking from the coffee, which is only really apparent on the acrylic. So you do get the benefits. So when you're using this sort of things, you have to get a balance. You may add some polyurethane to the acrylic resin, or you could also add a crosslinker. I can try and balance that out.
Well, we could really see the differences, but I guess something else that's important to our customers and to their end users is the scratch resistance of a coating and the mar resistance of it.
Yeah, it is really important to look at those areas as well, because like you say, a stain's one thing, but also a scratch or an abrasion mark is the same sort of thing, and it damages furniture. You don't want that to happen. So in this case, we can use silicone additives to improve the performance. They lower the coefficient of friction, so it'll improve the mar and abrasion resistance of the surface of the wood coatings.
I think we saw that really well, actually, didn't we? So we just applied the painter's standard on wood panels.
Yeah, like you say, it's the way they would be applied. Could be sprayed, but in this case we've just brush applied them. What we do for the test with this is we have the panel with the additive, without the additive, and we get some small 100 gram weights with some felt on the bottom, and we place them at the end of the panel, as you can see here, and we increase the angle, so we use gravity. If the surface has a higher coefficient of friction, it will just fall and it won't move, whereas the lower coefficient of friction on the left here, it will slide down, and because of the lower coefficient of friction, it'll be less prone to scratching or abrasion because it will just slide off the surface.
But interestingly, we measured the gloss of both the coatings as well, and even with the silicone additive, the gloss really wasn't reduced. So one with the additive, and the value is still quite high at 57.3. And then without the additive, you can see that it's just a very small difference when we've measured the gloss at 60 degrees.
We also now have a colorimeter, so we are able to measure colour in the LAB scale. The L value is either how black or white the material is, the A value is how red or green the material is, and the B value is how yellow or blue the material is.
Yeah, so I actually used the new colorimeter yesterday in the lab, and it's just so easy to look at the LAB values of each coating and compare them. So I would imagine you use this a lot when you've been looking at different titanium dioxides, different carbon blacks, for example.
Yeah, it's really important because if you want to be able to use alternative suppliers or different grades, you need to be able to make sure either you see a similar performance, or if you can see an advantage of using a certain one grade over another.
So we've looked really just sort of interior paint, the decorative wall paints and wood coatings. What about exterior paints?
One of the things with exterior paints, you've got to take into account the environment. One of the more common issues that we do have in pigmented systems is a phenomena called snail trail, caused when after you've applied your wood coating, your pigmented wood coating, that it starts to rain, as it does tend to in the UK. The rain runs down the surface of the wood you've just painted and it causes some pigment flooding, so it marks the surface.
So that's something we did in the lab as well, actually. Just painted wood panels with a pigmented waterborne wood coating. The one on the left contains just a small quantity of a silicone additive, whereas the one on the right doesn't contain that additive. So just applied the paint onto the panels and left it to dry so it was touch dry, and then just simply put some water on the surface. And what you can see almost immediately on the panel that contains the silicone additive, you do see quite a nice water beading effect, because this additive, with it being silicone based, has good water repellency as well. The one on the right doesn't contain the additive, and you don't get quite the same water beading, but when you look at the test now, we're just allowing the water to drip down the panel as it would if it was raining, and you can see that the one without the additive, you're starting to get these snail trail appearing as the pigment is sort of being washed out of the coating. And that's maybe a bit easier to see from this angle. You can see the water beading effect there, the water repellency quite well with the silicone additive. And then without, it is just literally going down the coating.
So if you've spent your day painting your fence outside, you don't want to then have loads of marks on the surface.
Well, it's been great to be back in the lab and to see all the new investment that's been made in the equipment that we now have here.
Yeah, it's really important because the main purpose of the lab is to support our customers and help them focus on solving their problems and improving the performance of their end products.
Well, I've really enjoyed the time here, so thanks very much, Chris.
Thank you, Sandra. Oh, God. I just